In this video, we're going to be looking at note sheet D5, which is focusing on vertical and horizontal shifts, and we're on page 3. And for this particular example, we're going to be looking at combining a change in period and a phase shift. And remember that the change in period is a horizontal change. It's either lengthening or shortening the distance on the x-axis that it takes to go through one cycle. And then the phase shift is the horizontal shifting. So we're combining those two. So all of our functions then are going to be of this particular form: y equals sine of b times the quantity x minus c, or y equals cosine of b times the quantity x minus c. And remember that those are both inside changes, and so that means that both of those are going to be horizontal changes. Notice the factored form. That's going to be important when we come down to the next problem, and I'll point that out as we go through the example. So in this particular problem, we're going to identify the amplitude, the period, and the phase shift of this function, and then we'll graph one period. So we're going to start out, first of all, by stating the amplitude. So the amplitude, remember, comes from the coefficient of the cosine out here in front. So the absolute value of 1 is just 1. The period of this one is going to change because we have a coefficient here in front of the x. So remember, the period is going to be 2 pi, let me come out here and write this, 2 pi divided by the absolute value of b, which is 3. The phase shift, before we can decide on the phase shift, we're going to have to put this into factored form. So I'm going to rewrite this as cosine of, and then what I'm going to do is factor this 3 out. Notice that the coefficient of the x that's inside here is 1. So whatever the coefficient is here is what I want to factor out. So I'll have x. Notice 3 times x will give me the 3x. And then I'll need a plus here because of the plus here. And now I need to decide what goes here so that this times this will give me pi. And so one way that you can think about this is that we're really just taking both of these terms and dividing them by 3. 3x divided by 3 gives me x, and so pi divided by 3 will give me pi divided by 3. This is a 3 here. So notice now if I distribute to this term, 3 times pi over 3 will give me pi. So now at this point, now that it's in factored form, I can use this to determine my phase shift or my horizontal shift. So because it's a plus, we know we're going to the left, and we're going to go to the left pi over 3. All right, so now when we start to sketch this, all right, we need to, first of all, maybe take care of the amplitude. So notice that there are no vertical changes on this, so it's not moving up at all. So that means that the principal axis will still be here. The amplitude is 1, so it'll still go up to 1 and down to -1. And then what we need to do is, again, decide what's going to go on the x-axis. And as we saw when we did the phase shift, just a plain phase shift without a change in period, that can get a little bit tricky. So I, again, recommend that you start out by coming down here and determining what those 5 values are going to be for the beginning, middle, end, and then the quarter point, and then the 3/4 point. And then once we have those, then we'll put those on our graph. All right, so this says that we're going to go left pi over 3. And so if we think about the point that on the cosine graph that's usually here on the x-axis, or on the y-axis, sorry, that point is going to shift, that's our reference point, it's going to shift left pi over 3. So that means that our starting value, instead of being here at 0 for x, is going to be at negative pi over 3. So that's going to be our starting value. So negative pi over 3. All right, then we need to decide what each of these values are going to be. And we'll do that by looking at the total period, which would take us from the beginning to the end, and dividing that period by 4. So if I take 2 pi divided by 3, and then divide it by 4 or multiply it by 1/4, then notice that what I'll end up with is pi over 6. And so that means that each of these jumps, 4 jumps, 1, 2, 3, 4, has to add on pi over 6. All right, so if I take a look at this one, I'll notice that the negative pi over 3 is really the same as negative 2 pi over 6. So when I add the pi over 6 to that, I'm going to get negative pi over 6. So that's going to be my next value along the way. All right, then I need to add another pi over 6. So if I add on another pi over 6, now I just get 0. That's an easy addition. Add on another pi over 6, so that's going to give me pi over 6. And then add on the last pi over 6, and that'll give me 2 pi over 6, which is the same as pi divided by 3. Right, and then remember, as I showed you before, once you do that, you really want to check the total period. In other words, if I jump from here all the way to here, is that total period 2 pi over 3? And we can see that it is. Certainly from negative pi over 3 to 0 is pi over 3, and then another pi over 3. Or you can just subtract the pi over 3 minus negative pi over 3. So I'm just subtracting the end minus the beginning. Just becomes 2 pi over 3. So that's a way to just double check and make sure that we have the correct values. All right, so now we can see when we're putting these values down that we have 2 values that have to go over here on this side of the y-axis. So I can just put down the negative pi over 3 and the negative pi over 6. The next one's going to be 0. I haven't done a good job of, let's divide this up a little bit better. Let's put this here and take that one away. So 0, right? And that makes sense because this negative pi over 6 should be exactly in the middle between those 2 values. And then the next one's going to be pi over 6, so I'll try to evenly space that one, do a better job with that. And then the last one, pi over 3. And of course, we can see the symmetry in this particular graph. All right, so now what we have is we've determined what the high or the maximum value is of the graph up here. We've determined the minimum value of negative 1. We know the left side of the graph is here, and then the right side of the graph will be here. And of course, this is still our principal axis. So just like before, we know now that the graph is going to be contained within this little box. And so if I remember what cosine looks like, that cosine at the beginning and the end starts up high, so the graph will do this. At the middle, which is 0, it's going to go down low. And then at the quarter and the 3/4 point, it's going to be on the axis, or on the principal axis. And so the graph will look like this. And remember, once again, you can use your graphing calculator to check all of those values.